Hi there and welcome to this video on presenting data. As well as various basic data representations such as bar charts that you may have come across already, there are several unique ones that perform well within higher education settings and you may come across within lots of research papers. I'll be looking at two of these today: frequency polygons and stem and leaf diagrams. In a frequency polygon, you're representing the same information that could be represented using a bar chart. For instance, let's look at this example. A class were asked how many siblings they had. Their results are shown in the bar chart here. So you can see that 5 people in the class had 2 siblings. 1 person in the class had 3, and so on. Well, why would we use a frequency polygon then? Well, a frequency polygon can be an easy way of comparing different sets of data on one set of axes. It will show the general trend of the data. We always plot it against the midpoint. So if I take this bar chart then, and I wanted to plot the frequency polygon on top of it, I would place the points in the middle of the bars to denote the frequencies there. I would then join them up using straight lines so that the first position is joined to the second is joined to the third is joined to the fourth, and so on. This means that there's no requirement to actually draw the underlying bar chart. For this reason, I could have 2 frequency polygons on the same set of axes, so I can compare 2 sets of data really easily. I can even put a third on as well. Just make sure that you include a key if you are comparing more than one set of data. You can also plot frequency polygons when you use grouped data. To do this, as we're plotting against the midpoint, we have to calculate that midpoint first. Have a look at this example. The weight of 100 dogs at a dog's home are shown in the table below. So we have 25 dogs that weigh between 10 and 15. We have 17 dogs that weigh between 20 and 25. To find the midpoints of those categories, you may remember from one of the last topics where we were looking at averages of group data in a frequency table. If you're not sure how to see what the middle point is, add the 2 endpoints of the group and divide it by 2. So the first one would be 2.5, because 0 add 5 is 5 and divided by 2 is 2.5. In the middle of 5 and 10 is 7.5. In the middle of 10 and 15 is 12.5. In the middle of 15 and 20 is 17.5. Then we have 22.5 and 27.5. I can now plot this as a frequency polygon. Here I have my weights on the horizontal axis, the x-axis, and the frequency always on the vertical axis, the y-axis. So the first one I plot is at a midpoint of 2.5 and a frequency of 4. 2.5 would lie in between 0 and 5, and I'm going to estimate that 4 is about there. 7.5 goes up to 13. 12.5 goes up to 25. 17.5 goes up to 32. 22.5 goes up to 17. And 27.5 goes up to 9. To finish it off into a frequency polygon, join the first point to the second point with a straight line, then the second to the third, third to the fourth, fourth to the fifth, and the fifth to the sixth. Of course, in real life, you could use a ruler to do this and it would be a lot neater. But I can see the general trend of the data and where the modal weights lie. We can do the same when it says group data as well. Pause the video, have a go how you would do it, and then press play when you're ready for me to go through the answer. Okay, so the group 0 to 10 has a frequency of 8. I need to plot it against the midpoint, which would be 5. So I'm going to go up from 5 to a frequency of 8. Then 15 goes up to 11. 25 goes up to 23. 35 goes up to 19, and 45 goes up to 15. So just be sure you are always plotting against the middle point of the group and joining the points from the previous one to the next one with a straight line. You may also get asked questions about a pre-drawn frequency polygon. Tia asked her friends how many times they visited the cinema last month. The frequency polygon shows her results. How many people visited the cinema twice? So here along the bottom we have the number of times visited. Twice is there. If I read up, I need to read that. So I can see that there was 28 people who went to the cinema twice. What is the most popular number of times that her friends visited? So I'm essentially looking for the highest point on my frequency polygon. That's this one here, which denotes going just once in the month. So going once is the most popular number of times. What is the most number of times that somebody visited the cinema? So I'm looking for the furthest along my horizontal axis. I can see the very last point is here, which denotes going 5 times in the month. And if I want to know how many people did Tia survey, I just need to add the frequencies. So I have 20 for this one, then I have 35, I have the 28 people who went twice, I have 13 people that went 3 times, 4 people that went 4 times, and 2 people that went 5 times. If I add all of those together, it gives me the total number of people that she asked, which is 102. Try these quick questions. You'll have 5 seconds, but if you need longer, just press pause and play when you're ready for going through the answers. So I want to know, where would I plot the group 20 to 30 against a frequency of 23? Would it be in position A, B, or C? Or does it not matter? Well, remember, you have to plot it against the midpoint. So it's the one in the middle of 20 and 30 and going up to the frequency of 23. That would be point B then. How many parcels weigh between 0 and 30 kilograms? So I need to add all of the points that are between 0 and 30, which would be this one, and this one. I don't include that last one because that's at 35, isn't it? So adding those together, I've got 4, add 9 gives me 13, add 5 gives me 18. So the answer is there are 18 parcels between 0 and 30. Have a go at this question. So I want to know how many students took between 20 and 25 minutes. So I can see on my frequency polygon, the horizontal axis, here's 20 minutes and here's 25. And there's one point in the middle of there. So that would denote all of the students who took between that time. If I read across, I can see that there's 5 students who took between 20 and 25 minutes. That's all for our frequency diagrams. So let's move on to the second popular one that occurs in higher education, the stem and leaf diagram. Well, a stem and leaf diagram is just a table where each data value is actually split into a stem, commonly the first digit, and a leaf. Here's an example. We have the numbers 15, 16, 21, 23, and so on. We've separated them into a stem, which is essentially the tens column within the number. And then the leaves, which are left over. So 15 is separated into a stem of 1 and a leaf of 5. 32 is separated into a stem of 3 and a leaf of 2, and so on. We always make sure that the stem values are listed vertically downwards and the leaf values go from right to left from the stem values. We commonly put the leaf values in order as well. Now the stem is what is used to group the scores or the values together, and then each leaf shows the actual individual numbers within the data set. Have a look at this one. Sam got his friends to do a long jump and got these results: 2.3, 2.5, and so on. Here's the stem and leaf. We have a stem of 2 and a leaf of 3. Here, that denotes 2.3, not 23 as before. So using a key alongside a stem and leaf diagram is absolutely crucial. The reader needs to know how to read the information and interpret it from the table. You can see we've got 2 5s here. We had to put this twice because in the data set there is also 2 2.5s. So if it occurs more than once, it will occur more than once in your leaves as well. We also have a leaf of 0, which sounds quite weird. However, remember, 5 and a 0 here would denote 5.0, which you can see is in your data set. So it's entirely possible to have a leaf of 0 as well, and if that's the case, you do have to include it. Let's have a look at this example then. Here are the marks gained by 30 students in an examination. I've separated them into their stems first of all, because I realised that the lowest mark was in the 40s and the highest mark was in the 80s. Therefore, I need stems stemming from 4, 5, 6, 7 and 8. We commonly don't miss out any stems, so even if there weren't any values in the 60s, I still would include a stem of 6. So if we have 63, that's a stem of 6 with a leaf of 3. 58 is a stem of 5 with a leaf of 8. 61 is a stem of 6 and a leaf of 1. So I'm just going to put a comma there. And I'm going to work through these until they're all filled in. I'd say the hardest bit here is making sure that you've included all of your numbers. So commonly people do like to cross them off to make sure that they've included them in their table. Here's my stem and leaf diagram that I've got. You may remember before I said it's common to write the leaves in order, but it can get a bit tricky to try and put them in the table first of all and order them at the same time. So I always start with an unordered version, and then I do my final diagram where I order the leaves. So for against the 4, I'd have 0, 4, 7 and 9. Against the 5 though, I'd start with the 2, the 3, and here this is when kind of checking them off becomes really handy. We've got a 4, there's no 5s, no 6s. I've got 2 7s, an 8 and 2 9s. You'd continue like that until you finish the stem and leaf diagram and all the leaves are in ascending order. Just some key takeaway facts then about stem and leaf diagrams. Always remember to include a key so that the reader knows how to interpret the data. Always put your data in order. Remember the stems go ascending order vertically downwards and the leaves go ascending order horizontally. We can work out some averages from this. One common one to find is the median. Now in normal you work out the median by putting them in order and finding the one that's in the middle. You can do that as well in the stem and leaf diagram, starting from the start and the end of the stem and leaf diagram, working inwards until you find the middle value. The range is also easy to calculate. You find the first leaf and the last leaf and subtract them. It's also easy to recognise the mode. You're looking for leaves that occur more than any other leaf. So if I look, we've got 2 5s. Oh, I've got 3 4s here. So that's the one that occurs the most. Now, a common wrong answer then would be to put that the mode is 4, but it's not. Remember to look at the key for how we're interpreting this data. It's with a stem of 5, so that means the mode is 54. I can find the range by looking for the first leaf and the last leaf in my data set. The biggest leaf then is 98 and the first leaf is 12. To get the range then, I subtract them. That would be a range of 86. And I can also find the median by working from the beginning and the end until I'm left with the middle value. So crossing off one from the beginning and crossing off the very last leaf, I'm working inwards. It's helpful because the stem and leaf diagram is already in order. I'm left with one value here of that 4 again. So the median is 54, read alongside the stem. Again, just like with the frequency polygons, a good way of testing your stem and leaf knowledge is not to actually get you to draw them, but just interpret data from within them. Here I have a stem and leaf diagram showing the height of Mrs. Smith's flowers. How many flowers does Mrs. Smith have? I need to count then the number of leaves. She has 19 flowers. The height of the shortest flower would be the very first one, which is this 9, and it says 0,9 is read as 9 centimetres. So 9 centimetres is the shortest flower. The tallest one would be the very last one. So that 5 and 3 is read as 53 centimetres. How many flowers have a height of 14? So I'm looking for a stem of 1 and a leaf of 4. That occurs 3 times. How many flowers have a height greater than 40? So that could be this 41, 46, 48, 48 again, and the 53. There are 5 flowers that have a height greater than 40. What fraction of the flowers have a height under 20 centimetres? So that could be the 9, this 12, 14, 14, 14, 18, and 18. So that's 7 flowers out of the total of 19. Fiona recorded the times it took 11 students to run 200 metres. Here are the times measured in seconds. Draw an ordered stem and leaf diagram. I can see that the shortest time then is 27 and the longest time is 50. So I need some stems going from 2 to 5. Now I'm going to do my unordered diagram first. So there's my 27, 38, 42, 35, 43, 49. I've got the 50, 37, 38, 41, and 48. And now I'm going to do my ordered version. So it has the same stems, 2, 3, 4, and 5. But this time when I copy them out, I'm going to make sure I put the leaves in order. So I only have a 7. For this one, I'd start with the 5, 7, and then 2 8s. Here I do 1, 2, 3, 8, and 9, and finally the 50. Make sure to put a key so I can say 2 and 7 equals 27 seconds. Work out the median time from my data set then. So remember to take one from the beginning and the end and go beginning and end. Continue like this until you're left with one value in the middle, which is this one. The median time is 41. The range is the biggest time, so that was 50. Take away the 27, which is the smallest time. That would be 23 seconds. And how many students finished the race in under 40 seconds? So that's this 27, 35, 37, and 2 people under 38. So that was 5 students. Here you've got 5 seconds to answer each question, but if you need longer, just pause the video and press play when you're ready. So which leaf occurs more than any others? I can see I've got 2 9s. So that one would be the modal answer. But it's not 9 that it corresponds to. It has a stem of 2. So it's the age 29. The stem and leaf diagram shows the ages of people in a shop. What's the median of the data? Okay, so remember, tick 1 from the beginning and 1 from the end. I'm going to do a few. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Let's do a couple more. 1, 2, 1, 2. I'm getting closer. 1 there, 1 there. I'm left with 4 and 9. So I need to find what's in the middle of 24 and 29. That would be 26.5. Here I have a back-to-back stem and leaf diagram. The left-hand side is showing me values for boys, and the right-hand side is showing me values for girls. I want you to find the median of the girls only. So let's start crossing off from the beginning and the end. Let's do 3. 1, 2, 3. Let's do a couple more. 1, 2, 1, 2, 1, 2. Right, I'm left with a 1 and a 2. I need in the middle then of 141 centimetres and 142 centimetres. That's 141.5 centimetres. That brings us to the end of our basic data representations. Have a go at the required material on the Moodle page or within the RISE programme to further practice this skill. Thanks for watching.